coffee roaster's primary tool is the roasting machine. Roasting machines come in all shapes, colors, sizes, of all different materials. So it's very important for you to understand your particular roasting machine. Most coffee roasters would refer to the drum roaster as really the artisan coffee roasting machine, although coffee can be roasted very well in a lot of other types of equipment as well. However, we're going to focus on drum roasters for our purposes here. Fundamentally, the roasting machine is a convection oven. It is a mechanism for inflicting heat, energy, onto whatever it is that you're cooking. In this case, we're cooking coffee. It's a convection oven that generally is in rotation and that is moving the coffee, transferring heat through a few different methods. Let's get nerdy about heat. Heat is thermal energy. There are certain laws of thermodynamics, or the fundamental understanding of how heat and energy transfer, that we can apply directly to coffee. This movement of heat energy is what we call heat transfer. There are a few different means through which heat transfers. First is conduction. This is the simple transfer of high levels of thermal energy to low levels of thermal energy through touch. For instance, when you fry an egg in a frying pan, that egg hits that hot pan, heat moves from the hot pan into the cool egg and cooks that cool egg. The second kind of heat transfer is convection, or the movement of hot molecules that are touching cooler molecules and transferring their heat. This is the kind of heat that we call fluid bed. If you have a fluid bed roaster, heat is transferred through the air moving the coffee around. The coffee is not coming into contact with a heating element or a piece of metal or something solid itself. The heat is being absorbed directly from the air that is hot. There is still an element of conduction involved in convection. However, that element of conduction is at the molecular level. So in a fluid bed roaster, the air is moving the coffee around. The air itself is hot. Those molecules of air are carrying the thermal energy to the coffee from the heating element, as opposed to the coffee collecting that from a drum wall or some other larger material. The third kind of heat transfer is radiant. It's a lot more difficult for us to measure and control in our roasting drums, and so we're really going to focus on convection and conduction. So now that we know that conduction plays such a vital role in the way that we heat our coffee, it's important for us to understand what kind of conduction is going on. The conduction from one type of metal versus another type of metal may be very different. Different kinds of metal will absorb energy at different rates. The rate at which that metal absorbs energy is congruent with the rate at which that metal gives off its energy. For instance, aluminum absorbs energy very, very quickly and gives off energy very quickly. If you take aluminum and put it over a fire, it gets hot right away. Once you take it away from the fire, it cools off right away. Inversely to that, we have cast iron. Cast iron takes a long time to absorb energy, and thus it also takes a long time for it to displace that energy into another medium. So understanding the metal that your drum is made out of is very important for you to understand how quickly that drum will give off energy and absorb energy from the flame. I hear a lot of roasters who talk about specific types of metal being better for roasting coffee, and that's a little bit of a misconception. In all reality, it's more important for the system itself to work to transfer energy in an effective way that you both understand and can control. Regardless of the type of metal that you're using, if the system itself is built around that type of metal, you can roast coffee extremely well. So I encourage you to learn more about what kind of metal your roaster is made out of and how that type of metal transfers energy. The other type of energy that we want to focus on is convection. Convection is, of course, a delivery source of energy. However, the more movement of air you have, the more the environment within your roaster changes. If you have an environment within your roaster of very high pressure, which is very low airflow, then you know that you are moving more toward a conductive style of heating. If you have lots of airflow and that air has had plenty of time to absorb heat from your burner source, then you know you're moving more toward a convective style of heating. A drum roaster is set up in a way to where you can switch between primarily using conduction and primarily using convection, or having an equivalency of both styles of heat exchange. Speaking of which, your roaster also has a heating element. There are all different kinds of heating elements driven by different types of fuel, such as propane or natural gas, or an electric burner. I've even seen halogen bulbs and other means of heating either air or a drum type medium. It's important for you to know what type of heating element you have and how many BTUs that heating element is able to put into your system. A BTU is a British thermal unit. It measures how much of that thermal energy you have the potential of putting into the system itself. The system itself is then designed to deliver that thermal energy to the thing that you are cooking, in this case coffee. So if you're able to put a lot of BTUs into the system, but that system is then sucking those BTUs out into the environment, that will affect the way that you roast your coffee. If you're able to put only a small amount of BTUs into the system, but that system is highly efficient and able to transfer those BTUs directly into the coffee, then you're golden. But understanding how much BTU bandwidth you have and how that is going to be an input into your coffee is fundamental to understanding how quickly, slowly you need to roast your coffee, or that you can expect that coffee to go through the roasting process. So that heating element that you have in your roaster is designed to either heat the drum or heat the air or heat all of the above. Most cases it's there to heat all of the above. In some roasters, that heating element does not have the bandwidth to heat large volumes of air. So at lower airflow levels, the air is being heated in a way that is efficient and can affect the coffee with more thermal energy. But if you start to bring more air volume through the burner system, that air volume doesn't have the time to get heated properly. And so as it moves through the drum, it actually will cool the drum. So therefore, it's very important for you to understand whether or not your heating element is designed for heating both air and your drum, and how much bandwidth it has to do both. Beyond the tools of simply heating the coffee or the cookery itself, you need to know what is happening within that drum. So most coffee roasters are equipped with temperature probes. Most of the temperature probes that exist out there are called thermocouples. These thermocouples are of different width. They're sometimes even of different material. Sometimes they read digitally, sometimes they're analog. Understanding your temperature probe will also give you more insight into what's happening in the drum. A very thick probe will have a lot of delay. A very thin probe placed correctly into your coffee bed will give you a lot of quick information about how your coffee is taking on energy. The probe is going to almost act like a scale. If you step onto a scale, it takes a moment for that scale to figure out exactly how much you weigh. There's a little bit of delay. There's noise in the environment. There's noise with the clothes you're wearing and things like that. The same thing is true for your temperature probes in your roaster. It's absorbing heat energy also just emanating from the drum, that ambient heat. It's absorbing heat energy from the air that's coming through your system. So understanding your probe, how it correlates to the system itself, will give you better insight into understanding exactly what's happening with the coffee while it's roasting. Put all of this together and you have your roasting system. So I encourage you, spend some time with your equipment. Talk to the manufacturers about all of these things that we've covered in this video. Get intimately engaged with your equipment and figure out exactly how your coffee machine roasts your coffee. Understanding your equipment helps you understand roasting and set you up to be a successful coffee roaster.